afternoon to all. Now I am going to deliver the lecture on the subject production technology. That is the course outcomes of the production technology subject. 5 course outcomes is there. Course 1 outcome is explanation of the basis of the casting and its application. Course outcome 2, demonstrate the various special casting processes. Course outcomes 3, distinguish between the among different joining methods. And course outcome 4, explain the basis of sheet metal forming process and plasting processing techniques. Course outcome 5, summarize the bulk metal forming process. In that subject, 5 units are there. Unit 1, introduction. Unit 2, special casting techniques. And Unit 3, metal joining methods. Unit 4, sheet metal forming process and plastic processing techniques. And Unit 5, bulk metal deforming processes. That are the required textbook. Textbook 1, Manufacturing Technology, authored by the P.N. Rao, Volume 1, TMH Publications, 6th edition. And second one is Hajra Choudhury, Elements of Workshop Technology, Volume 2, Media Promoters and Publishers. It will be published in 1994. First Unit 1 is Introduction. And end of the Unit 1, the student will able to learn the introduction and basis of casting and its applications. And in the Unit 1, that are the contents. First, introduction, engineering materials in properties and classification of various manufacturing processes. Second one, casting, introduction to casting, requirements of casting, step involved in making casting, and advantages of casting and its applications. Third one, patterns, type of patterns and materials used for patterns. Fourth one, gating, principle of gating system and gating ratio and design of gating system. Fifth one, runner and risers, type of functions and design of riser and cleaning of casting processes. That are contents under Unit 1. First one, introduction part. Under introduction, engineering materials and its properties and classification of various manufacturing processes. And end of this lecture, of this particular lecture, student will able to learn about the introduction of engineering materials and properties and the classification of various manufacturing processes. And first one, engineering materials and its properties and classification of different manufacturing processes. In every applications has different use of different materials, and different materials has different characteristics, different properties and different advantages and limitations. That materials will be used from aerospace application to household applications, and as per our requirement we use the different characteristics of different materials. Generally we have used 2 types of materials. One is extrinsic material, another is intrinsic material. In case of extrinsic material, we use some material, it will be added by external reinforcements, and by the internal reinforcements we have added some materials to the parent metals, and then the properties of that particular materials it will be different, and that properties will be more better than the parent metal, and also characteristics, advantages, disadvantages both are different with parent metal, means we get more advanced characteristics, and due to that advanced characteristics that material will be used to some specific applications. And another is intrinsic materials, some minor elements will be added to the parent material, and it alters some properties also with the parent materials, and Also, in that cases, the material properties, material characteristics, advantages, disadvantages, both are advanced than parent material, and these materials also use some specific applications as per our requirement. Why material science and engineering are important in case of technology or engineering sectors? First, in case of mechanical engineering or mechanical engineers search that type of materials. As example, if we take the gas turbine and jet engines, in that particular applications we use the high temperature materials. Means some materials are available in the world which will be sustained at higher temperature, and also it has more strength also. Okay, so in that cases, for that particular application of that materials we have used in case of mechanical engineering sector. In case of electrical engineers, use that type of materials which will be used and electrical for manufacturing the electrical device or electrical machines which will be run with faster rate with minimum power loss. So electrical engineers search that type of materials. That's why material science engineering also important in case of electrical engineering. In case of electronic engineers also search that type of materials for application of comfortable electronic parts, means miniaturized parts that will be portable and that will be more sophisticated for applications. Okay, so electronic engineer searches that type of materials which will be used for electronics sector. So chemical engineers search that type of materials which will be corrosion resistance materials, means avoided the rusting. So chemical engineers searches that type of materials and they use that type of materials for the particular applications. Classification, general classification of different materials. Generally we have divided the materials in 6 categories. First is ferrous materials, second is non-ferrous materials, third is plastic materials, actually it is included thermoplastics and thermosets, fourth one ceramics and diamond, fifth one composite materials, and sixth one is nanomaterials. Every materials and different application and different sectors. Means that type of materials has different application, different sectors, because every materials and different characteristics, different advantages and different material properties also, chemical properties, physical properties, mechanical properties, electrical properties. Means every materials have different properties. As per that characteristics and properties, we use that type of materials in different sectors. That are general classification of the alloy. Alloy can be divided into two categories. One is ferrous, another is non-ferrous. And ferrous materials also divided into two categories, steels and cast irons. And another, steels also divided into low alloy and high alloy. In case of low alloy, it will be divided into low carbon steel, medium carbon steel and high carbon steel. And in case of high alloy, it will be divided into two categories. One is stainless steel, another is tool steel. Ferrous materials, generally in our earth, generally two types of materials are available in the easily available in the market or available in our earth. First is ferrous material. That materials has main constituent as iron. That is the ferrous material, main constituent as iron. As example, such cast iron and wrought iron. Another thing is non-ferrous materials. Means it has no iron component. Means it has some other component. Okay. So when these some materials are available in the earth, they have no iron component. Okay. Means the in which have metal other than irons as their main constituents, such as example copper, aluminium, brass, tin, zinc. That type of material has no iron material. What are the characteristics of the ferrous material? First is ferrous material alloy contain main constituent as iron. Iron is the main base material in case of ferrous material. Second one is steel is a ferrous alloy. Some other alloy is there. So in that alloy main constituent as iron. Ferrous material has good conductivity property, good electrical conductivity property is there. And also it has, due to higher application of the load, it has also deformation properties also. And the main disadvantage of that ferrous material is the rusting, means it will form the oxides with air. So that is the main disadvantage of the ferrous material. Okay. Now what are the applications? That iron materials will be applied different sectors, means different sectors we have applied. As example, high rise building and also bridge construction, most vehicles, many appliances, tool, pipes, non-illuminated signs. So everywhere we have used the ferrous materials, and due to avoiding the resistance, so we form the some alloy materials we have formed, but main constituent iron, and with the iron we have added some other materials. As example, steel, that is also corrosion resistance materials. Okay. Cast iron is a brittle material and also it has some rusting properties, but these materials also it has good compressive strength and it will be used different applications, as like manhole covers, engine body, machine base. So in every applications also we have added that type of materials. My steel is a soft ductile material and it has also high tensile strength. So in that materials also have some particular applications like structural, workshop, household applications. So different applications have different material. And also carbon steels we have also used for as a cutting tools. Means as example, high speed steel is used as a cutting tool in conventional machining processes. Some classification of engineering materials. First one we will discuss about metal and alloy. What are the main characteristics of the metal and alloy? First one, the metal and alloy has crystalline structure and good thermal and electrical conductivity properties. Means crystalline structure means the 3D arrangement of the grains are regular manner. Okay, and also it has maintained the good electrical property and good thermal conductivity. Okay, means every metals and alloy has good thermal conductivity and electrical conductivity. Every metals has high strength and high hardness, and also it has high elastic module. Elasticity means when we apply the load to the material, it will deform, but after removal of the force, the material will come to the original position. Means so that material maintains the high elastic module. If it will, the deformation go beyond the elastic limit, so it will deform, means yield formation will take place to that material. And also some materials are there, it maintains the good strength and low temperature also. So in that material has some different applications also. Okay, and that material, some alloy materials are there and some metals are there that will also avoided the resistance also. So due to resistance to corrosion, that material has different applications also. Steel materials, main constituent as iron, but we added some chromium, some other materials also. Due to formation of the alloy material as a stainless steel, it has corrosion resistance property and it will be applied different applications such as biomedical applications, aerospace applications. So different applications we have used different alloy and also metals also. Ceramics, another type is ceramics and glasses. Ceramics also sometimes it will be, especially ceramics is a crystalline structure. Crystalline structure means the Arrangement of the grains are in regular manner. Non-crystalline glass is non-crystalline, means it has the arrangement of the grains are irregular manner. Okay, so sometimes the both materials also mixed and form the glass ceramics materials also. So that materials has high melting point and also high strength also there. So in that, due to that properties, we have applied different applications also. That materials also high hardness, high moduli and high temperature strength, means it can sustain at higher temperature also. Okay, and ceramics usually poor electrical conductor, so that's why it will not used as electrical sectors. Sometimes that type of materials will be used as a insulator. And ceramics has high strength to corrosion, means it has property of corrosion resistance properties also available in the ceramics material and glass material. That are the some properties of that ceramics and glasses materials. Polymers. Polymers are organic materials which consist of long molecular chains and networks containing constituent is carbon. And what are the properties? Generally polymers as a non-crystalline structure, means the arrangement of the grains are irregular manner. Okay, and generally it has low rigid and low densities, and mechanical properties may vary considerably, and due to lower strength, and it has corrosion resistance properties, and also it is not a good electrical conductor. So due to that properties, that polymers materials has different applications. Composite materials, generally in that cases two or more above materials are brought together and at macroscopic level, means above mentioned materials are added together and form the composite type materials. Okay, and that type of materials are consist of a matrix and reinforcement, and also that type of materials, as per our requirement, we design that type of materials to get the best properties which will be applied to the particular applications. And due to adding of different materials, the properties of the product material are different with the parent materials. So we get some advanced properties, advanced characteristics, and also changes the advantages and limitations also. Due to that characteristics, we have added that type of materials in different applications. Means some advanced applications we have added that ceramics materials. What are the mechanical properties of the metals? First one means what are the properties? Strain, stiffness, elasticity, ductility, plasticity, malleability. So different that are the mechanical properties. Okay, so what is strength? Strength means it is the ability of a metal to resist the externally applied forces without breaking or yielding. Okay, means strength means it is the property of a material we applied the force externally without breaking of the parent material. Okay, and what is the stiffness? Stiffness means it is the ability of a material to resist the deformation under stress. Means when deformation takes place due to application of the load, means what is stress? Stress means internal resistance per unit external applied force, means internal resistance occurred to the material per unit external applied force, that is the stress. Means the ability of a material to resist deformation under stress, that is the stiffness. Elasticity means it is the property of a material to regain its original shape after removal of the force within elastic limit. Means when we apply the force external to the material, so due to application of the force, the material will be deformed, means take that type of shape. Okay, and means it will be deformed. After removal of that force, means we remove that force. After removal of the force, that body comes to its original positions, means within the elastic limit means that is the elasticity. Okay, plasticity means it is the property of a material. When we apply the force to a material, means it will deform permanently, means after removal of the force it does not come back, means that is the material. We apply the force, means it will deform, means that is the original shape, but after application of force, just we consider that type of shape will be takes place, means after removal of that force it does not come back to this original position, does not come back to its original position, means it will follow that shape. So means that is called plasticity, means permanent deformation takes place, permanent yielding takes place to that particular material. Okay, another is ductility. Ductility means in case of any material, what happens now, when apply the force, the material drawn into wires, means it is the property of a material enabling it to be drawn into wire with the application of the tensile force, means due to application of force it will changes into wire shape. Okay, that is the ductility. Brittleness means it is the opposite of ductility. When we apply the force on a material, the material will be broken directly, means it does not changes into wire shape, means already I have told it is opposite to ductility. When we apply the force to the material will be broken, does not changes its shape, means directly it will broken, means that is the brittleness property, means permanent deformation, permanent distortion takes place to that particular material due to application of the force. Malleability. In case of malleability properties, when we apply the force to the material will be changes into thin sheets, not drawn into wires, means due to application of the force to the material it will be changes into thin sheets, as like thin sheet will be formed in case of malleability property. Toughness. Toughness means the shock absorption capacity, it is called toughness, means property of a material to resist fracture due to high impact loads like hammer blow, means it to resist the fracture, means formation of the fracture, it resists the formation of the fracture due to high impact loads, means like hammer blow. When impact loads or hammer blow is doing on a materials, due to impact loads or hammer blow, the material may be deformed, or may be fracture. So in that cases, so what happens, means some absorber we have used some vehicles, so it will absorb the impact loads like hammer blow, means the shock absorption capacity is called toughness, means it is the property of the material to resist fracture due to high impact loads. Machinability. What is machinability? Machinability means the material has ability to cut the other material. High speed steel used as a tool material, that materials had more hardness to cut the other materials, means machinability means it is the property of a material which refers to relative case with which that material can be cut, means the materials has ability to cut the other material, means as example high speed steel has a higher strength and it will cut the other material easily. Okay, that is the machinability. Another is resilience. Resilience means it is the property of a material to absorb the energy. When we deformed and when we expanding the material within the elastic limit, so at that time material absorb the energy and to resist shock and impact loads, means resilience means it is the property of a material which absorb the energy when it will extend it. When it will extend it, or it will be apply the impact loads. So at that time it will absorb the energy and also resist the shock or impact loads. That is called resilience. Creep. Creep means a constant stress applied on a material at higher temperature for long period of time. When we applied the constant stress at higher temperature for long time, so some slow and permanent deformation takes place to that material. What is the condition? We applied the constant stress. Second one, higher temperature. Third one, for long time. So due to that three effects, the material deformed, under material take permanent deformation to that particular material. That is called creep. First one is constant stress we have applied, number one. Second one is at higher temperature. Okay, and third one is long period of time. Means three conditions are required in case of creep, and due to that three reasons, the slow and permanent deformation takes place to that particular material. That is called creep. Fatigue. What is fatigue? Means in that cases we applied the repeated of stress, means repeated of loads we have applied to that material, and due to application of repeated loads and repeated stress, it fails at stresses below the yield point stresses. Means it will fail permanently below the yield point stress. We know first limit. So in case of stress strain diagram, as example we have taken. So here proportional limit is there. So after that elastic limit is there, and then yield point, lower yield point, then upper yield point, and after that here ultimate strain, and at the end of the point the breaking point is there. Means below the yield point the materials will be fails due to application of the continuous repeated loads. Due to application of the repeated stress, the material will be failure below the yield point stresses. So such type of failure is known as fatigue. Hardness means it is the improperty of the material. It resists the scratch formation, and also it resists the wear formation, and also it resists the deformation, and also it resists the indentation. So that thing is called hardness. Means it resists the formation of any type of wear, tear, scratching, deformation. So that property is called hardness. Now, in case of classification of manufacturing process, before discussing that thing, I have discussed some preliminary thing about the manufacturing process. First is production. What is production? But what is the difference between them, or it is same? In case of production process, the converting the input into outputs. In case of production process, it convert the input into outputs. Okay, and it is a border term. Means it is a border term. Here consideration of the production economy, it is mandatory in case of production. Okay, and in case of manufacturing, what happens? Now converting raw materials into finished product using some various processes, labor, machine, tools, chemical and biological processing. So different things we have used in case of manufacturing. Okay, and also it will start with product design, material specification from which the product is made. Okay, so different things is required in case of manufacturing. It is a narrow term. But consideration of the production economy, it is not mandatory in case of manufacturing. Consideration of production economy is not mandatory in case of manufacturing. So both are different, but as per layman, manufacturing and production are same term, but it has some differences. Means that is a broader term, that is a narrow term. But in case of manufacturing, we will not consider, it is not mandatory for consideration of the production economy. But in case of production, consideration of the production economy, that is mandatory. Okay. Some examples of the production means Toyota, Panasonic, LG, Samsung and Tata Motors. That are the some companies are there that will be, that are a production plant. If we consider Toyota automobile plant, so in that industries, so they are producing different cars, and also for producing the cars, different parts, chassis, gears, axle, different parts are produced. Means producing the different parts, that is the manufacturing. But that plant means industry plant, that is called production plant. Means production is a bigger term and manufacturing is a small term or narrow term. Okay. Some example I am taking in case of USA, America, labor cost is high but machining cost is low. But you are taking that both thing, means labor cost is high but machining cost is, because machine is manufactured in that country but labor cost is high. So if both are added, so in that cases we have seen that toy can be manufactured at high cost. Okay. In India, relatively labor cost is very low but machining cost is high, because machines are not produced in India. That very sophisticated machines are produced in different developed countries. So we have purchased the different precise machines and sophisticated machines. That's why, so for manufacturing any type of thing, that is produced at high cost. At high cost of production, the product will be manufactured. But example, in China, labor cost is also and machining cost are cheap. So in that cases, we have seen that the product will be manufactured at low cost. So best place is preferred for production any type of thing. So companies are preferred in China, because both costs are cheap. That's why they prefer the place China. In generally manufacturing process are two types: primary manufacturing process and secondary manufacturing process. In case of primary manufacturing process, they provide the basic shape and size. Okay, as per designer requirements. Okay, casting, forming, powder metallurgy, they are produce the basic materials. But secondary manufacturing process provide the final shape and size with tighter control dimensions. Means with accurate dimensions we have got using secondary manufacturing process. Means all the material removal process by conventional machining process or by advanced machining process, both are material removal process, and that material removal process are secondary manufacturing process. Means by the removal of the material we have got the finished product. In secondary manufacturing process, we have got the finished product using the secondary manufacturing process. Secondary manufacturing process means material removal process. Maybe conventional machining process, maybe advanced machining process. Both are material removal process, means both are secondary manufacturing process. By using that processes, we have got the finished product. Material removal process means secondary manufacturing process. We have divided two types. One is conventional machining process, another is advanced machining process. Example of conventional machining process: drilling, boring, milling, shaping, broaching, slotting, grinding, that are the conventional machining process. In case of advanced machining process means unconventional machining process, that is electrochemical machining, laser machining, electron beam machining, ultrasonic machining, abrasive jet machining. that are the advanced machining process. Both are material removal 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 processes. Okay, means advanced and conventional and advanced means non-traditional machining process means advanced machining process. That is also called unconventional machining process. Unconventional machining process. Unconventional machining process. Unconventional machining process. Okay, so both are material removal processes. Okay, means that is the secondary manufacturing processes. What are the characteristics are non-traditional machining characteristics with respect to conventional machining process? So, in case of non-traditional machining process or advanced machining processes, metal will be removed as a atomic level and also no chip formations in case of advanced machining processes. But as example, we have taken electrochemical process. In electrochemical process, the metal will be removed by electrolysis method. In case of ECM process, ECM means electrochemical machining process. In that process, the metal will be removed by electrolysis process. Electrolysis process. The metal will be removed by electrolysis process. That is the main principle of the ECM. Okay, means here metal will be removed at atomic level. Material will be removed at atomic level. At atomic level. So means here no chip will be formation. So in case of non-traditional machining process, but in conventional machining process, chip will be formed. Chip means maybe continuous chip, and conventional machining process maybe chip will be continuous chip, maybe continuous chips or discontinuous chips or build up edge. Three types of non-continuous chip means discontinuous chip. Discontinuous chip, discontinuous chips, and third one, number 2, number 3, build up edge. Build up edge. So three types of generally, then another selected chips are there. Generally we have taken three type of chips will be formed during conventional machining process. Means here metal will not remove atomic level. Means using some machines, conventional machining means lathe machines, grinding machines, milling machines, shaping machines, drilling machines, different conventional machining process we have used for manufacturing of the finished product. Another, in case of NTM, no physical contact to the tool and workpiece. Means if you are we will consider that is a workpiece, okay, and that is a tool. You consider that is a tool, okay, that is a tool fixed with the some other conventional machining process. Means if that is the tool and that is the workpiece, in case of conventional machining process, physical contact has been present to the tool and workpiece. Means here more energy will be used in case of conventional machining process, and sometimes the chip means continuous discontinuous build up chips will be formed. That chip sometimes may be affected the operators. But in case of NTM machines, non-traditional machining process, there is no physical contact with the tool and workpiece. So here no affected means any operator does not affect. means no effort is there during operating of the machines in case of non-conventional machining processes. Okay, means as example we taken laser beam. We use laser beam for removal of the material. Easily we remove the material using laser beam process. Means no effort is there. Okay, so easily we remove the material using the laser beam. Okay, third one is the in case of non-conventional machining, means non-traditional machining process, no need to, means tool need to be, not need to be harder than workpiece. Means it is not necessary the tool will be more harder than workpiece. It is not necessary because no contact between tool and workpiece. No contact means that is the tool and that is the workpiece, means no contact has been present to the tool and workpiece in case of non-traditional machining process. So that's why no need to be that, no need that tool not be harder than workpiece. It is not required. But in case of conventional machining process, tool must be harder than workpiece. Means in conventional machining process we use high speed steel. We use high speed steel. Means it is generally harder than other workpiece. Means using that material, it is used as a tool material and it is harder material and easily it will cut the other material. Okay. So HS is used as a tool material. So that are the some main characteristics with respect to non-traditional machining process, and also I discuss about the characteristics of the conventional machining process. Some classifications. What are the classification of the processing techniques? Means forming process. What are the forming process we have used? Okay. So first is primary forming process, second is deformative process, third one is material removal process, fourth is joining process, other is finishing process. Means that type of process we have used in our manufacturing sector for producing the different products which will be used in our daily life. And also different materials and different properties. So with respect to that different mechanical properties, chemical properties, we use different manufacturing processes for getting finally the finished product. And from that lecture, concluding outcomes of that lecture, students have been learned from this lecture the introduction to engineering materials and its properties, different properties of different materials. Also, they learn the classification of the different engineering materials, and also they have learned the classification of the various manufacturing processes also.